Today we'll talk about systems of linear equations. A system of m linear equations with n unknowns defined over the field of complex numbers is an expression of the form we see on the slide. It consists of a series of coefficients, a set of n unknowns, and also m independent terms. Recall that both the coefficients and the independent terms must belong to the field of numbers in which we have defined our system of linear equations. The solution of a system of linear equations is given by a set of values ordered from k1 to kn in such a way that if we replace the values of k1 to kn by x1 to xn, each of the equations defined in our system is fulfilled. Systems of linear equations are classified according to the solutions they have. Incompatible systems have no solution. Compatible systems do have a solution, and within this classification, two types can be differentiated. Determined systems have a unique solution. Undetermined systems have multiple solutions. Equivalent systems of equations are those that have the same solutions despite being different. Here we can see an example of a linear equation that is x1 plus 6x2 minus 4x3 equals 5. If we multiply that equation by 2, we would have 2x1 plus 12x2 minus 8x3 equals 10. If we solve these linear equations, we can see that they have the same solutions. The same happens if we multiply that linear equation by minus 1. The elementary transformations are transformations that when applied to a system result in an equivalent system. Recall that the equivalent systems are those that have the same solutions. These three elementary transformations are: exchange equations, multiply an equation by a number other than 0, multiply an equation by a number other than 0 and add it to another equation, replacing it with the result. We will see some examples to make it clearer. In the case of exchanging equations, literally means that if you have a series of equations and you change the order of them, it doesn't affect the system. They are equivalent systems and they have the same solutions. The second elementary transformation refers to multiplying a linear equation by a non-zero number. It's like the example we just saw, in which we have a linear equation and we multiply it by a scalar, in this case number 2, and it returns a slightly different linear equation, but it has the same solutions. And finally, multiply an equation by a non-zero number and add it to the equation, replacing it with the result. This case may sound a little bit more complex, but in reality it is not. Here we can see an expression in which we multiply the first equation by minus 1 and then add the second equation to get a new equation. So if we multiply by minus 1 the first equation, we would have minus x1 minus 6x2 plus 4x3 equals minus 5. And if we add the second equation to that expression, we have 4x1 minus 7x2 plus 5x3 equals minus 4. This equation is a new equation that emerged from the linear combination of the other two equations. Then we can replace the second equation with the equation that was obtained from the sum, and that results in an equivalent system. Well, that was all for today. I hope you liked the video. Don't forget to subscribe to the channel, and if you have questions, please write them in the comments. See you in the next video.